Back. This is section 11.4 on temperature and volume. This is another scientist that gets his name on a law. There's very, very few laws in science, only a few, handful. And this is one of them. Nobody contests this. Everybody believes he was right. So Mr. Charles, whoever you were, you're awesome. In any case, we see that the volume and the temperature also have a relationship. We've already studied Boyle's law, which was pressure and volume, and those are inverses. So as the volume decreases, the pressure increases. Well, in this case, we're studying the volume and the temperature. Okay, so if you were to increase the temperature, let's say of the ocean, would the ocean stay in the same space? No, it's actually going to increase. What you're going to see is as water is hotter, it's going to expand. I use this every single day as I make coffee. I have a percolator on my stove. I put water in the bottom of the coffee pot. I put some coffee grounds in the little pan at the top. And then as the water heats on the stove, it expands. And as it expands, it goes up through a little tube on the inside of the coffee maker and then spews out onto the coffee and gets darker and darker. The longer that it perks, the darker it gets. That's the expansion of the liquid based upon the temperature. So we're going to see that this is a relationship that's called direct. As temperature goes up, the volume goes up. Now, as people worry about the climate getting warmer, if the climate gets warmer, one of the problems is that the ocean, all that ocean water is going to be bigger than it used to be. The volume of the ocean is going to increase as the temperature increases. And if the volume of the ocean is bigger, that means the same amount of water takes up more space. That water has to rise up on the beach and actually flood a lot of places along the coast. And the problem is that there's lots and lots and lots and lots and lots of people that live there, okay? And especially a lot of poor people. And that's where you're going to have some problems. Okay, so let's look at this. So the direct temperature, okay, as the temperature increases, then the particles are going to bump more. And as the particles bump more frequently, the pressure goes up. And if the pressure on the side of the balloon goes up, then it expands. So the volume goes up. So if you take pressure out of it, you end up with a direct relationship that as the temperature goes up, the volume also goes up, okay, of that gas. Anytime you're using the gas laws, this is not difficult. All you're going to do is realize that the volume and the temperature are related directly. So as one goes up, the other goes up. So we'll see this direct relationship. That anytime that you have a direct relationship, you're going to have temperature and volume on opposite sides of the equal sign. All right. So look, if I had V1 equals something times T1, as V goes up, T goes up. You see? So I have, if they're equal to each other and volume is going up, temperature will go up. So in order to have both of them, you're going to end up with a fraction here. Volume divided by temperature 1 equals volume divided by temperature 2. All you're going to do to solve is solve for 1. Get 1 by itself, and then put the other 3 on the other side and multiply and divide until you get the answer. All right, so in this case, Boyle's law was P1V1 equals P2V2. This one's going to be V1 over T1 equals V2 over T2. Use the gas laws to complete the following statement with increases or decreases. Pressure does what when volume decreases? Okay. If volume decreases, the pressure is going to decrease or increase. Okay. Well, we know that volume and pressure are inverse. So they are going to go opposite. So when volume decreases, pressure has to increase. What about temperature? When temperature decreases, what happens to volume? Well, they go together. Temperature and volume are a direct relationship. So as T decreases, V is going to decrease. So when volume changes from 12 to 4, so you're dividing it by 3, pressure multiplies by 3. Pressure triples. Okay. What about volume? When temperature changes from 15 to 45, so that's tripling, temperature triples, what happens to volume? It triples. So volume and temperature are related directly. Okay. So if you're going to solve for T2, how do you do that? I don't want something on the bottom, so I need it on the top. So if it's on the bottom on one side, I'm going to move it to the top on the other side. Okay. Now I need to get rid of these two. This is on the bottom on this side, so I bring it to the top on this side, so it'll be V2 times T1. Then this is on the top, I bring it to the bottom, V1 on the bottom, so I have T2. So when you're solving, you have to solve for it on the top. You can't solve for it on the bottom. Okay, so T2 has to be in the denominator, or on the numerator first, before you can do anything with it. And then you just rearrange it. I call moving the furniture. You're just moving this and then moving this and moving this until you get the one by itself that you want. Everything else is on the side. So you get an example. They give you a milliliters, that's volume. They give you a temperature. They give you a new temperature. What is the new volume? Okay, well, you solve for new volume. You solve for V2, get everything else together and put them in and multiply and divide until you get the new answer. Okay, so once you solve for the new volume, this would be V1 T2 over T1. You fill in those three, the V1, the T2, the T1, multiply top times top, divide by bottom, and you'll get your new volume. Not hard at all. I think you can do this. Sample of oxygen gas has a volume of 420, temperature of 18. At what temperature will the oxygen be 640? That means you've been given a new pressure, okay, or a new volume. You have an old volume, V1, T1, okay, and you have a V2, and you're solving for T2. So you get T2 by itself, fill in the rest, multiply and divide until you get the answer. Okay, so T2 equals T1 V2 over V1. Fill in those three, multiply the top, divide by bottom. You end up with 443. And then they gave you a trick here at the end. They ask for Celsius degrees. And to go from Celsius to Kelvin is you're adding 273. So Celsius plus 273 is Kelvin. So if you want Kelvin, you're starting with Kelvin, you go back to Celsius, you have to subtract 273 to get Celsius. So you end up with 170 degrees Celsius. All right? Again, we'll play with this until you got it.